Good day, students. Welcome to mathcodeserve.com. In this clip, we're going to be comparing two methods of solving finite limits of the indeterminate form. We're going to be looking at algebraic limits and L'Hopital's rule. So we're going to solve one problem using two methods and basically see what your opinions are as to which method is superior in solving the particular problem under consideration. So the task is to find the limit as x approaches 1 of 1 minus the square root of 2x squared minus 1 divided by x minus 1. Now, whenever you're given a finite limit to evaluate, we know this is a finite limit because you're approaching a finite number here, namely 1. Anytime you're given a finite limit to evaluate, the first approach you want to use is to substitute. Okay, just substitute first to see if you can evaluate it by direct substitution before you try to start doing using other elegant methods. Okay, so let's substitute first. We're going to substitute 1 for all the x's in this expression right here. So we'll have 1 minus the square root of 2 times x squared. So instead of x, we'll put in a 1. Square minus 1. And then the entire thing is going to be divided by 1 minus 1. Alright? So this is going to become 1 minus the square root of 1 squared is 1 times 2 is 2 minus 1, and the denominator divided by 0. Okay? Now, if you take a look at this form right here, is this an indeterminate form, or is it undefined? Well, we have to simplify the numerator completely first before we are in a haste to conclude if it's indeterminate or undefined, which could indicate that the limit does not exist. So simplify it completely, okay? So we have 1 minus the square root of 2 minus 1, which is 1 over 0. And then we have 1 minus 1 over 0. We have 0 over 0. So this is of the indeterminate form. Okay? So if you have a limit that's on the indeterminate form, it basically means that we have to use another approach to try to evaluate the limit. Okay, so this is where we're going to use two different methods. I'll try to put them side by side. So method 1 that we'll use is the algebraic method, okay, using algebraic method. And then we'll be comparing it with L'Hopital's rule, which is more involves the use of calculus. Okay, so we have this limit that we're trying to evaluate right here. Limit as x approaches 1 of 1 minus the square root of 2x squared minus 1 divided by x minus 1. Now, when you have an indeterminate form and you want to use an algebraic method, you ask yourself, how can I rewrite this in such a way that I could eliminate that root that's causing, or that factor that's causing there to be a removable discontinuity? Okay, so you can either factor, expand, but in this case we have a radical situation here. So anytime you have a radical component and it's of an indeterminate form, you want to rationalize. Okay, you want to rationalize the radical component. The radical component is the numerator here, so we will be rationalizing the numerator. How do you do that? You multiply by the conjugate. The conjugate involves just inverting the sign between the radical piece and the part that's not a radical. So we're going to have 1 minus, instead of minus we have plus root 2x squared minus 1, and then that divided by 1 plus root 2x squared minus 1. Now what we have what we are trying to create in the numerator is a difference of squares. Okay, so you have a minus b and a plus b. So you remember that if you have a minus b times a plus b, that's the factored state of a difference of squares, so it comes out to a squared minus b squared. Now if you forget this fact, you can always distribute. It takes you longer, but you end up with a squared minus b squared because the middle terms will be opposites of each other. So I'm going to use the formula. So we have, this is a plus b. This entire radical piece is b, okay? And a is 1. Let me fix that. It's a minus b. So this is a minus b. And this is a plus b. So we're going to have a squared minus b squared. Okay? So what is 1? Well, let me just show you the steps so no one gets confused here. So we have 1 squared minus the square root of 2x squared minus 1 square. Okay, the goal is to express the numerator in such a way that we are squaring that radical component so that the square and the square roots cancel each other out. And the denominator, don't expand the denominator, just leave it just as it is, because we're trying to see if we can get rid of this x minus 1. That might be a removable discontinuity factor for the original function. So let's just leave it like this and see if we can cancel that out. Okay, so this is what it looks like. Now what we're going to do next is we are going to proceed to simplify the numerator. We have, let's see, 1 square is just 1. The square root and the square cancel each other out. So we have 2x squared. Now you have to be careful here because we have a minus there. This minus multiplied by that, we change the sign to a plus. So it's going to be plus 1. And that entire thing divided by the denominator. Please don't alter the denominator in any way. Just leave it just like that, so we don't confuse ourselves. So we have 2x squared minus 1. Okay. Now, if you look at the numerator, there are like terms that can be combined. You can combine 1 and 1. So you have negative 2x squared plus 2. And you have that divided by what? Divided by the denominator, which is x minus 1 times 1 plus root 2x squared minus 1. Okay? Now, in the numerator, I could factor out negative 2. Remember, the goal is to express the numerator in such a way that I could possibly cancel out x minus 1. But we are not there yet. Let's see how we can manipulate the numerator in such a way that that move is possible. Okay? So I factor out negative 2, and I have x squared minus, note, anytime you factor out a negative, the signs of the terms that you factor that negative from will switch, right? It becomes opposites. So this becomes x squared minus 1 divided by, the denominator stays the same as we mentioned earlier. Don't alter that piece. X minus 1 times 1 plus the square root of 2x squared minus 1. Okay? Now, what can we do to the numerator so that we can cancel x minus 1? If you take a close look at the numerator, you will notice that we have a difference of squares again. We have a squared minus b squared. But this is it is in its expanded form. So what we're going to have to do is factor it and see if we can get x minus 1 as one of the factors. Okay, so if we factor the numerator, that gives us negative 2 times x plus 1 times x minus 1. Voila, that's exactly what we're looking for. So that x minus 1 causing the 0 in the denominator can be eliminated, and hopefully we do not have an infinite discontinuity after that removable discontinuity has been eliminated. So we have x minus 1, 1 plus root 2x squared minus 1. Okay, so these x minus 1s divide out conveniently, and we have negative 2 divided by negative 2 times x plus 1 divided by 1 plus the square root of 2x squared minus 1. Okay, so this is exactly the same as the original limit expression we're trying to evaluate. All we just did is we altered the way it looks using the algebraic processes. Okay, so the problem is still the same. It hasn't changed. It just looks different. We're evaluating the limit as x approaches 1 of negative 2 times x plus 1 divided by 1 plus the square root of 2x squared plus 1. Now what are we going to do? After our algebraic manipulation, we're going to substitute again and see what happens. Now with substitute, we have negative 2 times 1 plus 1 divided by 1 plus the square root of 2 times 1 square minus 1. Okay, let's simplify that further. If we simplify further, we're going to have, let's see what we have. Negative 2 times 2 over 1 plus the square root of 1 squared is 2 times 2, 2 minus 1, which is equal to negative 4 over 1 plus root 1, which is negative 4 over 1 plus 1, negative 4 over 2. And as you can see, our final answer is going to be negative 2. Okay? So that's how to evaluate that limit using the algebraic method. Okay? Alright, now let us evaluate the limit, the same limit using L'Hopital's. So L'Hopital's rule method. So the question is, when can you use the L'Hopital's rule? You can't just use L'Hopital's rule for any problem. You have to have an indeterminate limit, a limit of an indeterminate form, in order for you to be able to apply L'Hopital's rule. Okay? So what is L'Hopital's rule? Let's go ahead and consider that. L'Hopital's rule basically states that if you evaluate a limit and you have an indeterminate form, the result of the limit is the same thing as evaluating the limit of the derivative of the numerator. Okay, notice how it's separated. The derivative of the numerator divided by the derivative of the denominator. Okay? Derivative of the numerator divided by the derivative of the denominator. We're not differentiating the entire thing. We're separating it, doing the top and the bottom separately. Okay? We're not dealing with the... If we were differentiating the whole expression here, we'll have to use the quotient rule. But that's not what we're doing. We're separating the numerator and the denominator. Okay? So let's go ahead and apply L'Hopital's rule here. Now, the deal with L'Hopital's rule is that you need to be good with your differentiation rules. If you haven't studied differentiation, for example, in the some of the earlier lessons in AP in calculus, um, the concept of derivatives has not yet been covered, so you can just use algebraic limits. In that scenario, this method is not applicable because you have not mastered the art. But if you've mastered the art of differentiation, then you can use L'Hopital's rule. So that's the deal there. Okay, so we're going to go ahead and differentiate the numerator and denominator separately. Since we have a difference, we're going to carry out term-by-term differentiation. So when we differentiate 1, the derivative of 1 is 0 because it is a constant. Now, if you take a look at this function, this is a composite function. It's a composition of a radical function and a quadratic function. Okay, so we're going to be using the chain rule here. Anytime you have a composite function, you want to use a chain rule. And we're going to be using this shortcut right here. You do not have to use it. You can use the power rule by all means. But if you have the derivative of a radical function, root u is the same thing as 1 over 2. So root u prime, 1 over 2 root u du dx. In this particular problem, u, the inner function, is 2x squared minus 1. Okay? So when we differentiate the outer function, the radical function, we're going to have 1 over 2 roots. This u, 2x squared minus 1. And then we'll multiply it by du dx, which is going to be 4x. Okay? So that's just the chain rule right there for u. Now let's go ahead and apply it. If we apply the chain rule here, we're going to have, for the radical function, the outer function, 1 over 2 root u. So it's 1 over 2 root u. U is 2x squared minus 1. We have differentiated the outer, evaluated at the inner, times the derivative of the inner function, which is 4x, using the power rule on 2x squared minus 1. Sorry, the derivative of 1 is 0. Okay, so we have it set up like that. And then the denominator, we'll just do term-by-term differentiation. The derivative of x is 1, and the derivative of 1 is 0. Alrighty. Now let's simplify. So we have limit as x approaches 1 of, we can carry out a reduction here. 4x and the 2 can divide out. Let me not do that yet. Let me just rewrite it first so that nobody gets confused. So we have negative 4x divided by 2 root 2x squared minus 1. Minus 1. Let's do that again. Okay. So we're dividing by 1. So when you divide by 1, it doesn't change anything. Okay. If this were a fraction or a number, you can just express it as a fraction and multiply this by the reciprocal of that. As you can see, it doesn't change anything. Okay. You can divide a 2. 2 goes here, 1, 2 goes here, 2. And then you're now going to have the limit as x approaches 1 of negative 2 x, negative 2x divided by what? Divided by root 2x squared minus 1. So all we have just done so far is we just differentiated and simplified our result. Now we're going to evaluate the limit again. Okay, we're going to substitute again and see what we get. So when we plug in 1, we're going to have negative 2 times 1 for the numerator divided by what? Divided by the square root of 2 times 1 square minus 1. Simplify that, we are going to get negative 2 divided by 2 times 1 square is just 2, so we're at 2 minus 1 and that is, let's see what we get, negative 2 over root 1, which is just negative 2. Okay? And that's the same as what we got over here. So there goes L'Hopital's rule, L'Hopital's method of evaluating limits of the indeterminate form. So the question is, which method is more powerful? Which method do you prefer? So we'd like to hear your comments as to which method you prefer. Just post it in the comment section. Thanks again for watching this presentation. As indicated earlier, you can post your comments in this comment section below. And if you found the contents of this presentation helpful in your study of limits, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to other math tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.